So we've reached the end of the first part of this presentation. We now move on to the importance of data analysis, the why and how, as well as its applications and implications. First, a brief look into the evolution of data analysis from its early beginnings in statistics during the 17th century to the need of governments to make their census data, take them into account more mechanically without the manual human labor. We reached the computational advancements of the 20th century, where computers finally allows us to edit and analyze complex and data with much more volume than before. We see the first database systems in the late 70s and early 80s. We move on to the age of statistical software and spreadsheets like VisiCalc and later Microsoft Excel. And finally, we come to today with the internet and the data explosion, where we, as we mentioned, leave our digital footprint and saw an explosion in the e-commerce sector. Specifically, during the 21st century, the big data term emerges, as well as machine learning and artificial intelligence. We see the need for a multidisciplinary approach, many different fields from data science to physics to mathematics coming together to provide the expertise needed. We see the open source movement where programming languages like R and Python gain popularity. And we come to modern decision making in big companies or organizations where data analysis becomes a major strategic asset and a tool for real-time analytics. And looking into the near future, we can expect a continuous evolution of this field, but also we must take into account the ethical and regulatory landscape, which many countries still have yet to develop properly. So data analysis is critical for informed decision making, for its predictive power, and for its efficiency and cost savings. I'm going to skip this because we're running out of time again, but the whole presentation will be available online, of course. We see now the rise in big data, which, as we mentioned before, is characterized by the four big V's: the volume, velocity, variety, and veracity. So let's discuss each one of those terms more in depth. The volume describes the amount of data transported or stored. It is predicted by the IDC that the increase of volume will be at a compound annual growth rate of about 23% over the next 5 years. So while it may be theoretically still able for traditional data storage systems to handle this amount of data, in reality, we see that these methods are already struggling to keep up. Variety describes the many forms that data can take, most of which are rarely ready for processing or analysis. This is why preparing data is so important before analyzing them. The most major contributor of big data is unstructured data, specifically video, images, multimedia in general, which are estimated to represent 80 or up to 90% of the world's data today. It goes without saying that these formats are too complex for traditional data storage architectures, and this is why the unstructured data makes up a significant portion of big data, which does not fill in tabular systems and so on. Velocity is the rate at which the data is generated. For example, the stock exchange market generates huge amounts of data in very short amount of time, which must be analyzed and reported immediately. Otherwise, big companies lose a lot of money. This data infrastructure, therefore, must be able to instantly respond to changes in demand, in application requirements, etc. And finally, we have veracity, which is the process of preventing inaccurate data from spoiling our data sets. For instance, we all know that there may be false accounts created on a social media platform, for example, which is why it's crucial when someone is making data analysis on such a platform must first realize which of these users are real, which are fake. Otherwise, the conclusions drawn from such an analysis may be completely false. This is the importance of veracity, therefore, in data. Now we can see a simplified view of a data pipeline. It starts on the left with the ingestion of data, which in simple words means the acquirement of data either from servers or IoT devices or sensors in general. That kind of data is then stored before it is transformed, which means that it is first filtered for bad data or data that is not relevant to our project. And later on, the remaining data is converted into usable formats. After that is done, we store the resulting data either on cloud storage, online storage, or maybe in the case of sensitive data, for example, this storage may be on premises, locally saved, in other words. Let's view now the life cycle of data analysis. So this cycle consists of 8 parts, and it repeats every time. I will explain a bit more as we go on. This life cycle of data analysis encompasses a series of steps that data undergoes from its initial acquisition to the final use of its results. This process is cyclical and iterative, often leading back to the start. The first part is data collection, of course, which is from where data can be sourced, like databases, surveys, social media, we mentioned that before. The goal at this stage is to gather high-quality relevant data that is suitable for an analysis. Then we move on to data processing and cleaning, where all data that is incomplete or inconsistent or has error is disregarded or fixed up, let's say. It is transformed into the format that we desire and that is suitable for an analysis, which leads us to data analysis, where our analytical models and techniques are applied. A few examples of these are statistical analysis or data mining or machine learning, using machine learning algorithms, or any other kind of methods that we can use to test a hypothesis and to generate insights. After that, we are able to visualize our data, which is a very important step, especially if we want to display our results into the public or into customers or coworkers, which may not have the same kind of expertise as we do and need to be easier to understand. There's the interpretation of the results, especially through visualization, which means converting what we just acquired into business insights and generally making sense of the numbers and patterns we see in the context of our objectives. Then we can make decisions about how a business, for example, can make strategic changes, become more competitive, etc. Those decisions lead to actions, whether it's changing a process or developing a new kind of product or adjusting a strategy. All those things are actions taken, which then we can evaluate through feedback and refinement, see what worked, what didn't, measure its impact, and carry on from the beginning of the next cycle to better refine and optimize our analysis and decisions. So, as we mentioned, the life cycle has a cyclical nature. It's characterized by iteration and adaptation, depends on the quality of our data, of the skill and the interpretation abilities of the people involved, how well it integrates in our business processes, the technological infrastructure available, as well as complying with ethical and legal constrictions. But what are some popular tools used in data analysis? We'll review a few basic categories briefly. There are spreadsheets, which are probably familiar to everyone. This includes Microsoft Excel or Google Spreadsheets, and are used for basic data manipulation and analysis. For more advanced analysis, we go to statistical software or programming languages designed for this kind of things, such as Python or R, which have very powerful data analysis libraries. And then we have the database querying languages, the most famous of which is SQL, or data visualization software to visualize, as we said before, the results of our analysis. Such software is Tableau or Power BI. Now we'll expand a bit more into the specifics of a few of these program suites. Excel, for example, may be a more powerful tool than many realize. However, it's only suitable for small data sets and for quick data analysis. In Excel, someone may be able to perform data cleaning, format and adjust data, perform calculations, even create visualizations like simple graphs and charts. Moving on to SQL, which is structured query language. This is a much more powerful database management tool, which allows even experienced data analysts to retrieve and interact with selections of data stored typically in relational databases. Moving on a bit briefly to another visualization software. This is Tableau, which is used to data visualize from market data, for example, and it can even work with sources like Excel spreadsheets and SQL databases, which we mentioned earlier. Now, I have a small video of about 5 minutes, which delves into 10 of the most popular free dataset resources. So we will try and watch that for the next few minutes. Δεν ακούνε. Oh, sorry, I need to share the sound. Πώς κάνω στο sound? Τι εννοείς?
Δεν ακούμε τι λέει. Δεν ακούμε.
Okay, I know you couldn't hear that. Let me start it again.
I would suggest to share. I would suggest to share the video link at the chat, please. So if people cannot hear it, that they might be able to view it at their own time, or at least have it. Okay.
Yes, okay. That can be done as well. But let me see if I can make it work. Possible, I can share some. Θες να το προσπεράσουμε. Πού λέει διώξη. Ωραία. Μωρά αυτό. Τώρα θα κλείσουμε. Άστο μωρέ, στο μετά, δεν πειράζει. Okay, sorry about that, since we can't really share the sound. It's a small video, so you can watch it at your own leisure later on. It will be included in the presentation. Besides, okay. So moving on, there are two examples of big data technologies. Just for reference is the Hadoop ecosystem and Apache Spark. Now, what are some analytical techniques in data analysis? There is descriptive analysis used to describe the basic features of the data, diagnostic analysis, which focuses on determining the causes of certain events, predictive analysis, which employs statistical models and makes forecasts. You can imagine the weather model, for instance. Prescriptive analysis, which goes beyond predicting future events and also suggests actions that can be taken to influence outcomes. For instance, in healthcare, a model may not only predict that the patient may have a certain disease, but may also provide some helpful to the doctor suggestions of how to deal with it. And finally, machine learning contains advanced techniques which allows computers to learn from data by themselves and make decisions on their own with minimal to no human intervention. And this is a new way of programming we've seen only in the last few years or the last decade. What are some real-world applications now of this kind of thing? Well, we have the applications in the business and finance sector, as you can see on the presentation, on the slide. This may include market analysis, financial forecasting, management. In the healthcare sector, education, I'm not going to read all of that. You can do it yourself. Retail, technology and social media, and in environmental science. How does the data analysis shape our decision making more specifically? Well, we can view the role in that data analysis plays in informing and shaping our decision making by separating into various domains. So starting with informed strategic development, this is the analyzation of historical data, which can predict patterns that will arise in the future. It is essential for enhancing customer understanding, so business can use their data to gain insights into customer preferences, behaviors, feedback, etc. It can be important for optimizing operations, identifying bottlenecks, inefficiencies, and creating best practices to avoid them. and risk management and mitigation. With the use of data analysis, a company may predict potential risks and by the use of preemptive measures, mitigate them and avoid them entirely before they even happen. It may also be useful in financial planning. Think about budgeting and forecasting investment trends. In policy making, in the public and law sector, data analysis may provide helpful insights to policymakers. In advancing healthcare, as we said before, a doctor may be able to give a better diagnosis or be aware of more suitable treatment plans for a patient with the use of data analysis systems. It drives innovation by analyzing market trends and advancement in technology. We can better identify opportunities for innovation. And finally, for tailored education, institutes may use data analysis to tailor the learning experiences to a particular student's needs and their abilities. And finally, a bit before the break, the implications of data analysis can be divided in 8 different categories, starting with business strategy and competition. There's the strategic insight and the innovation that it provides to businesses and companies. The economic impact can be found in the job market evaluation. There are already systems that use data analytics for finding the best candidate for a particular job, for instance. And resource allocation in resource management and crew management fields. There are the social and cultural effects, of course. Behavioral insights may be given from monitoring online behavior and cultural trends. The personalization of application, as we said in the very beginning, like the algorithms used in YouTube or TikTok. There are the ethical and legal considerations, which are only now starting to become apparent, and countries are starting to make their own new laws, like GDPR, for protecting the customers and users from bad use of their private data. There's data governance, what security measures can be taken to maintain the security and integrity from data against breaches and misuse. And finally, global dynamics include the international relations and the access and equity to all this data. And finally, we come to the technological advancements in the last few years, which are the artificial intelligence, machine learning, and even more cutting edge, the quantum computing, which is still on its very infancy. So